Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video, we're going to look at a previous exam question. This question is from the 2024 Higher Level paper and it's question 10b. This question was tricky because it didn't give us the differential equation. It was required of students to create the differential equation, which proved problematic. So let's work through it. A tank of uniform cross-sectional area contains water of height x meters. Water leaves the tank through a pipe at its base. The rate at which the height of the water decreases is proportional to x. So as a student, what you need to be able to do is take a sentence like this and convert it into mathematics. So the rate, unless they tell us otherwise, that's going to be d something dt, and that's true for maths as well. So the rate at which the height of the water. Now here's what's important. It told us the height is x meters. Okay, so the height is x. There is a h in the question, but they're telling us the variable they're using for height is x. And it decreases proportional to x. So it is proportional to a decrease, which means minus and x. So this idea of proportional, we've got a proportional symbol, decreases is minus, if it's increase, it will be a plus. I'll just put a circle around that so it looks clearer. One main issue, a lot of students put in dt was proportional to minus x, which caused a problem. So just be really, really careful. So the second thing that we need to do in order to make this a differential equation is get rid of that proportional sign. So proportional, all we're going to do is put in an equals and then a constant. So we're going to have a minus k x like that. That's enough to put in our equals. So proportional means as one goes up, the other goes up or down, as in this case. So putting a k, a constant in front of it as a coefficient will create that equation. So now that we've done that, we're going to separate our differential equation and solve it. So I'm going to bring the x over, but I'm going to leave the minus on the right hand side. I prefer to leave my minuses on the right if I can, because generally they're going to be easier to work with. So then we have when the time is 0, x is h. Now, it's completely up to you how you want to do this. Some students will go and work out, let's find an equation or an expression with x and t. I'll go straight to when t is 45, x is h over 3, and this will effectively get us a value for k. So integrating that left-hand side, that gives us the natural log of x, which we evaluate between h over 3 and h, and then we get minus kt, which is evaluated between 0 and 45. So that is the natural log of h over 3 minus the natural log of h is equal to minus k times 45 minus the minus k times 0. So I'm going to just ignore that part. So this is the natural log of, using our laws of logs, h over 3 divided by h. So that's natural log of a third, which is minus k over 45. Sorry, minus 45 times k. Now, if we get rid of this minus by bringing it over, so if I put the minus here instead, then I can bring this as a power. Think of your rules of logs. So the coefficient becomes a power, so it's 1/3 to the power of minus 1. So that's the same as the natural log of 3 is equal to 45k, which gives us k is equal to the natural log of 3 divided by 45, which is kind of nicer than putting in a specific decimal, but if you want to put a decimal, that's absolutely fine. It works out as 0.0244136. Now that we've got a value of k, we're basically going back and doing the same question, but we have different limits. Now, like I said, it's absolutely fine if you want to work out an expression for x and then sub in and get your k and then sub in again. And this is, minus k over, and that is dt. So we know when t is 0, x is h, and we want to find the time when x is h over 8. Now, here's the good news. I've already done a lot of the hard work. So I know this becomes ln, and it becomes the top number divided by the bottom number. So I get the natural log of what is effectively h over 8 divided by h, which is 1 over 8. So that speeds me up a lot. Here, this is just a constant, so nothing's happening to it except we put a t there. And now what we have is same as before, natural log of 8, which gets rid of that. And then I'm going to divide that by 45. Sorry, divide that by natural log of 3 over 45. And that will give us our value for t. I personally don't like writing a lot of decimals. If you want to change any of these to decimals, you can. That's absolutely fine. But this works out as 85.2 seconds. So not a bad question. I think the setup really was what limited a lot of students.